Hello and good afternoon. I'm Elif Uysal, founder and CEO of FRESHDATA Technology, which set out to revolutionize communications for IoT and space. I'm an electrical engineer and I was elected a fellow of the IEEE, Institute of Electrical and Electronics Engineers, due to my pioneering contributions in energy efficient and low latency communication. So I decided to turn these novel research results into products in a timely fashion in FRESHDATA Technology. Now, this news item appeared earlier this month, and it says, IoT is South Africa's next big leap, especially when combined with artificial intelligence. As you know, IoT stands for the Internet of Things, which is everywhere today. Farms like this can use IoT to make sure they water the crops only as needed, saving precious resources. Utility companies detect losses early, saving billions of dollars in repairs, and supply chains can reduce waste and make operations more efficient. So it has been recognized that IoT is necessary for sustainable development. But there's a problem, and the problem is connectivity. Now, when these sensor devices, these low-power battery-operated devices are deployed out in the field in vast areas, how do they reach the internet? Of course, they're not going to use Bluetooth, which is very low, short range. They're not going to use Wi-Fi. It's too power hungry. So new technologies have been developed, like LoRa, like NB-IoT. Problem is, even these new technologies do not scale to the 50 billion IoT devices expected by 2030. So this is where FRESHDATA comes in. But first, let me give you two examples of the connectivity problem in two use cases selected among the countless use cases in IoT. Now, consider a forest fire early detection scenario with 5,000 sensors deployed in an area around 100,000 kilometers in Europe, which is, of course, very modest compared to the vast areas here in Africa. But these sensors in this environment experience congestion and a packet success rate, meaning a connectivity that is only 10% of the time when it is most needed. Now this translates into the delayed detection of fires by 10 to 30 minutes. 30 minutes means the fire spreads 5 times faster. Another more commercial example is ships arriving at a port, much like the port here in Cape Town. Now, around 8 ships approach the port every 15 minutes. These ships are equipped with lots of sensors, and they're trying to send AIS data to the port to safely come into the port. However, if you can believe it, the industry standard for AIS communication right now allows a successful reception rate up to 30%, meaning more than 60% of the connections are lost. This delays the safe entry of ships to the port, resulting in hundreds of millions of dollars in fuel consumption, extra fuel consumption. Now, the connectivity problem also exists in urban IoT. 20 to 30% of IoT nodes experience connectivity problems, as well as in industrial settings. This is up to 40%, and translates into hundreds of terawatt hours of energy consumption predicted by 2030. So what is the root cause of the problem? Why is IoT not scalable even with the latest technology? The reason is the way we think of transmitting data, which is legacy from 1980s, from TCP, IP, etc., where data arrivals are extrinsic to the network. At FRESHDATA, we address the core of the problem. In 2015, I published a paper which introduced a paradigm shift. We shift our focus from sending data faster at high throughput or low delay into sending data that is fresh, meaning data that will be fresh by the time it is received. So it introduces new KPIs into networking, and basically the main idea is waiting can be anti-aging, meaning we sample and send data responsive to network conditions so that data is not going to get stale by the time it's received. This problem evolved into what we call goal-oriented communication, which means send the right data to the point of computation at the right time. Right data means useful data. So, for example, with much less samples sent per minute, we can achieve freshness, reducing also the big data explosion problem, especially in power grids. Now, at FRESHDATA, we turn these ideas into proof of concept products. We have a lineup of products. First is the LoRaWAN relay that uses the LoRa technology, which is the fastest developing IoT communication technology out there. And it reduces deployment costs by 20% and OPEX by 60%, but more importantly, it is the world's first goal-oriented communication relay. Secondly, we have a semantic grid monitoring device for power grids, also have been implemented in POC stage. And we have, next up is our satellite relay, and we have built a non-terrestrial networking patent portfolio. Now, in the interest of time, I'll only tell you about our relay product. Consider the scenario where this node, the node on the top cannot reach the gateway because of the long distance, and the second node cannot reach the gateway because of blockages. Now, there's an existing LoRa relay standard out there. However, it is not backward compatible. So it does not match the existing LoRa nodes that are out there. Enter the FRESHDATA relay. It is totally backward compatible and operates seamlessly with the nodes that are out there, requiring no changes to the legacy nodes. More importantly, the FRESHDATA relay is the only goal-oriented and age of information aware relay that's out there, which translates into 2 times higher network capacity on the ground and twice more network capacity when equipped with sophisticated channel encoding mechanisms. Now, in terms of the technical specification, our relay is battery powered, operate with for several years on AA batteries, low cost and very lightweight. Currently, we're in the demo stage with potential customers. Earlier this week, we were in Amsterdam in the Things conference, which is the main LoRa event. And here, there's a picture with FOSA, which is a satellite operator. So satellite operators actually need us because they need to gather valuable data from the ground so that they make each satellite pass count, so that they reduce their OPEX costs. And the number of the satellites they are needed in their field, in their fleet. Now, in terms of the current business, again, our target customers are utility satellite service providers as well as utility providers. Our business is inherently globally scalable because we are using and contributing to global communication standards, and pretty much the same devices operate with very little change across the world. We started in Turkey. We're currently expanding to Europe, and then we plan to expand globally around 2027. It is exciting that a whooping 73% cumulative growth rate was recorded in the global LPWAN IoT market in 2024. Our team, we have a core team of 9 people with fascinating engineers from PhD level all the way to just junior engineers. Süleyman is here with me. He's our project manager. We have built an IPR to protect our ideas, and our business model includes licensing agreements, direct sales, and R&D corporations. For the rest of this year, we've lined up some pilot projects with several companies, as well as some subcontracting agreements with Germany and with Turkish Telecom. In 2026, we plan to get some grants, but we're really looking for seed funding to take our business to the global scale. Thank you for listening.
What a presentation. What a presentation. Judges, let's go.
Elif, yeah, this is it's quite impressive. I'm trying to think how it will work in Africa, seeing that, we've got limited, very, very limited satellite coverage, and your main customers is satellite. And therefore, I think it will probably be down the line for you to think of expanding into Africa. Because connectivity is the biggest problem that we do have in Africa, and beyond that is also energy problems, etc., etc. And I think your solution is quite dependent on, having the energy to be able to connect, having the satellites to be able to communicate to, etc.,
Actually,
etc.
Given the limits, thank you. That's a very good point. That allows me to clarify. I've emphasized satellite providers here in this presentation. In 10 minutes, it's hard to explain the entire technology. Our customers are any IoT deployer,
Okay.
as well as those that use satellite IoT. So if you were an IoT deployer on the ground or even indoors, for example, gas meter monitoring. This is a real use case where some meters are in lower floors and they're not reachable by the gateway. And installing relays is a low-cost solution rather than installing more gateways. Plus, the relays do not need internet connectivity. They do not need the power grid. Since power grid is not needed for the relay, it is an exciting use case for areas like long distance, including long distance links in deployments in Africa, for example. Where spreading these relays out there is a cost-efficient solution in terms of energy and money.
Thabo.
Just a quick one. Your relay, is it compatible with Sigfox as well? Because I know that in South Africa, there's a lot of Sigfox networks.
I know. Right now, we're using LoRa. But the core idea, the goal-oriented communication, can work with the Sigfox system because we're not touching the physical layer. Our ideas are in the application layer and some in the link layer. That's why, in fact, we're backward compatible.
Wow, can you feel the passion here? I feel it. What fantastic stuff. Thank you very much. Give it a big round of applause, please.